There are lots of really good detailed videos on the history of the structure of the atom. This is meant to be a very brief summary to help you get to the bottom of what you know for your GCSE, right? So you need to know that people way back in ancient times, so ancient Greece, Democritus suggested that the building block of all matter is atoms, and he sort of said that the idea that atoms are these building blocks, and you should know that atoms are considered the building blocks of all matter. And so he just assumed that there's these little circles, if you like, right? Nice and simple for now. You're not going to be asked about Democritus. But then many years later, I'm not worried about years, you need to know anything about years, but Dalton came along. So the Dalton sort of came up with this idea again that things are made of atoms, but he suggested slightly differently that there's different types of atom. So maybe atoms of hydrogen or carbon or nitrogen or oxygen or whatever it might be. So and he sort of drew little pictures on them to make them look like different things. So different types of atom make up matter. And so often, if you look at these different pictures here, the kind of Dalton model of the atom were just the blobs. You didn't know how they were different, but you knew they were different. So D would be the kind of Dalton model, just a circle that is the atom. But then came along the plum pudding model of the atom. Importantly, this followed the discovery of the electron by J.J. Thomson. So J.J. Thomson discovered the electron. I'm not going to discuss here how he did that or how he knew what it was or anything like that, but the key thing is you need to know that the electron was discovered. And he knew that the electron was negatively charged. He found that the electron was negatively charged, and so it suggested that the atom must be made up of something that contained electrons. So this is B, so this is the Thomson model or the plum pudding model, which you've heard of, okay? Plum pudding. And the idea is that these electrons are kind of studded in to an atom, and in order to be overall neutral, the atom he decided must be positively charged, this kind of sphere of positive charge with the electrons studded in, or embedded in, if you like. So electrons embedded in a positive sphere or positive cloud. So electrons embedded into a cloud of positive charge. That's the kind of plum pudding model, and that's B there. So we've done D, and we've done B. And then eventually Rutherford came along. Now I'm not going to talk you through the Rutherford experiment. There's lots of videos to do that and do that really well. But that's very briefly the experiment that involved firing positively charged alpha particles at some gold foil and all the scattering that went on. I'm not going to talk about that in detail. What you need to know is the key points, and that's the purpose of this video. So it told you that the nucleus is positively charged, and also that the nucleus is tiny compared to the size of the rest of the atom. You could put it slightly differently and say the atom is mostly empty space. And so that led people to think the atom was something like C, right? Something like that. So a positively charged, tiny nucleus. And look at the model, look at how it works, look at why they came up with those conclusions, but know those conclusions at least for your basic idea of what the atom structure is. And then Bohr came along. And I'm not going to make any attempt at all to explain to you how he knew this, but he worked out that rather than just an electron shell or electron shells just randomly with electrons going round in them, he worked out that there were electron shells of different energies, or if you like, of different distances from the nucleus. So he worked out there were different electron shells around the nucleus. and each of those had a specific energy. And all the stuff we've done in the past about electrons would most likely to fill the inner shell first, and higher energy or electrons added afterwards to go in outer shells. So that was Bohr, so multiple electron shells. And that's that picture there. Except this picture also has got neutrons showing. And you're expected to know that Chadwick, after Bohr came up with the idea of the neutron, he realised there must be a particle that had mass that wasn't accounted for by the model up to that point. So atoms had more mass than was accounted for by the protons alone. And so there must be another particle. He worked that they were neutrons. And that, I'll remind you now that you've got to know about isotopes at this point. Atoms can have different numbers of neutrons without changing their chemical properties at all. Chemical properties are dependent on protons and by extension electrons as well. And so looking at this exam question here then, which one shows the plum pudding model? Well, that would be B. Which one is derived from the alpha particle scattering Rutherford experiment? That would be C, which gave you this idea of a tiny nucleus that's positively charged. Which one came from Bohr's work? Well, that would be A. Let's just finish off by looking at a couple of exam questions on this. So question 4.6 here, Chadwick's experiment. So we know he's the guy that invented the neutron, discovered the neutron. His work led to a better understanding of isotopes. How does this work lead to better understanding? So mentioned that he discovered the neutron, and then be clear that the definition of isotopes, or that the definition of isotopes is the same number of protons, or isotopes have the same number of protons. And if you get a question like this, you're not really quite sure what the mark scheme is getting at. It's telling you about isotopes. Tell the examiner what isotopes are, and they have the same number of protons and different numbers of neutrons. So that's what isotopes are. There's another question here, last thing we'll do on this video, another question here from 2008, 19 I think it is. So the plum pudding model was the ball of positive charge with electrons embedded in. Evidence from the alpha particle scattering led to a change in the model from the plum pudding model. Explain how. And as I said, there's many videos that do a better job of explaining this than I'm going to try to do, but remind you that alpha particles pass through the gold foil to a very large extent. So the vast majority, I should say most here, so vast majority of the alpha particles pass straight through, and that led to, as we've said, the understanding that most of the atom is empty space, or the nucleus is tiny, or most of the mass of the atom is in the center. So mostly empty space. Atoms are mostly empty space. And some alpha particles were deflected or reflected. Let's get that key right, the key word right. Deflected or reflected. They didn't bounce off. Don't use that word. So deflected or reflected. Look back at the videos of that if you're not sure what it's about. And that told you that the nucleus was positive charged. I should write positively there, but I'll put it shorthand. That's it. Thanks.